Okay, so what you're going to do for assignment number 2 is you're going to draw a basic vapor compression system which will have your condenser, compressor, evaporator, and expansion device. Very basic, okay? And then you're going to show that the air on temperature, so you're going to actually go here and get your thermometer. You're going to draw a little thermometer because because you're a very diligent guy. You draw a little thermometer, and you're going to show that you have your air on temperature. So you're going to put your probe at the air onto the condenser, and you're going to give it a temperature. You're going to see that it's 20 degrees Celsius, okay? You're then going to get your thermometer and you're going to stick it in the middle of the coil. You're going to show that you have in the middle of the condenser, you have your probe in the middle of the condenser, and you're getting a 35 degree temperature, right? And then you're going to explain that the rule of thumb is that the condensing temperature must be anywhere between 10 to 20 degrees above that of the air on temperature. So if I take 20 from 35, the difference there is 15 degrees Celsius. So just by using a thermometer, I can confirm that with a delta T total of 15 degrees, I actually have a good condensing temperature there. 35 degrees is a normal condensing temperature for the condition that my evaporator is under. Now, if you wanted to show off and have a little bit more wording, what you could do then is you could turn around and say, should the air on increase from 20 to 25 or to 30 degrees, then you would expect your condensing temperature with a 15. At the moment, there's a 15 degree delta T total here. So if I increase it to 30 degrees and I add 15 to 30 degrees, I would expect my condensing temperature to be up at 45 degrees Celsius. That makes sense? So that's what assignment 3 is about, is showing that you understand that 35 degrees today could be 45 degrees tomorrow, all right? Or it could be 25 degrees next in the winter time. And the reason why I'm trying to get across to you, or the principle that I'm trying to get across to you, is that the condensing temperature is very much dependent on the air temperature coming onto the condenser. So if I have an air temperature of 20 degrees, my expected condensing temperature would be 15 degrees above that. But it could be anything as low as 10 degrees above that or anything as high as 20 degrees above that. But as long as it's within that range, 15 would be the norm. But on a cold winter's day, if my ambient temperature drops to 10 degrees, so will my head pressure. On a real hot summer's day, if my ambient temperature goes above 20 degrees, so will my head pressure. It's the very same principle that in my cold room, if my cold room temperature is 2 degrees, my back pressure will drop. If my cold room temperature is 10 degrees, my back pressure will increase. So the warmer my room temperature, the warmer my evaporating temperature, the warmer my ambient temperature, the warmer my head pressure. Is that fair enough? That's what assignment 3 is about.